All right, so welcome to Financial Algebra. It's week 8, and some of you have joined us late, and they still think you can like crank it out and get her done. And if you can't, just communicate with me so we can keep an open dialogue and see where you're at, so that way you can get credit for this quarter. So we have 3 people who voted, and I'm going to put my vote. What would I vote? I'd vote for this one. That's what I would vote for. Okay, so what I want you to do is I want you to think why you voted for the one that you did and kind of defend what you picked. So first thing you need to do is take over one of those student windows. So students 1 through 7, we only have 2 of you today. If Gateway Classroom and Central Classroom wants to participate too, somebody can jump on that computer. And so Miriam's overtaken student number 2, Jeffrey will overtake student number 3, and I will overtake student number 4. And like I said, what I want you to do is I want you to tell me why you picked the one that you did. Okay, and then Gateway's not even answering, and they're the ones that picked one of them. Oh, I hate that. Cool. It's okay. Okay, so Miriam would pick $60 a month. So would Jeffrey, because I have lots of expendable income. And I would do pay per use because nobody ever calls me. One of the things, though, I liked what you guys pointed out is you are willing to pay for better coverage. There's certain cell phone services out there where the coverage is spotty or it drops more calls, and there's people like you who dropping of calls and being spotty is not acceptable, so you're willing to pay an extra $10 a month or 15, whatever it is, to do that. I have a friend of mine and she uses Google Voice, and so she actually uses her computer for her telephone, and then it forwards it to her track phone if she's not home. And so she pays like $3 a month on her cell phone. She doesn't talk to anybody, and if she's going to talk to somebody, she waits till she gets home to talk to them. So the next thing I want to do is we have a lot. Oh yeah, I forgot. 6 objectives, our warm up. We answered the poll, and we didn't enable your mics, but hopefully you know how to. And if you want to talk, you can. I think typing is also comfortable for you guys, and that's fine. We'll talk about the budget in just a minute. I want to talk about the objectives. We're going to look at utility expenses, graphing a piecewise function, and you should be able to write a piecewise function and graph one as well. And I'll show you how to use Desmos.com to graph a piecewise function. It's really fabulous. It's super cool, by the way. So I want you to think about the discussion, and I'm highlighting it in red and making it even bigger. A budget tells us what we can't afford, but it doesn't keep us from buying it. So think about that for a minute. Well, just 30 seconds. All right, that was only 10 seconds. So I want you to, in your pod, to put, what do you think this quote means? Okay, so I like the thoughts. Miriam's pointed out that there might be something out of our price range, and then we could save for it. Yeah, yeah. You coming for the webinar? Okay. So Miriam's thought is that it's out of our price range, and then um, people want them and they still buy them. And sometimes we buy stuff on credit, which if you can avoid that in your life will be a whole lot better. And then Jeffrey, I like what he said. People would still purchase something that they don't make enough money for or need. And one of the things I wanted to kind of point out along with that quote is sometimes we have our wants and our needs and we mix them up. Sometimes we want something so bad that it's like, no, I gotta have it. And it's really not a gotta have it, it's a flat out I want it. And so budgeting helps us, I think, put certain things in perspective as to, do I really want it? Do I really need it? And if I really need it, then I can just put some money aside. Each month I put some money aside for my kids in their college, and I think by the time that they get to college, it'd be like 10 bucks, the rate the college rates are going up. But so I mean that's something that I want, and I hope that they want. Um, and just doing that. So let's go to showing some of our piecewise functions, and you can see that you're still somewhere. Well, that kind of shifted you a little differently than I thought it would, but that's okay. Colorado has a stipend out there, so I don't know if that's what people are kind of talking about. It's called the Colorado Opportunity Fund, and so if you put, all you have to do is just sign up for it, I think every semester or once a year, and then they take away some of your tuition, so they give you a tuition break. That'd be cool if they pay. I'd have to go back to college if they wanted to pay me. So we're going to look at the cost of cell phones and graphs because you guys are pretty familiar with cell phones and graphs. And I want to first talk to you about a step function. A step function looks something like, I gotta find where my spots are. Gotta draw spots. Red's gonna be good. Step function looks like steps. Can you see that? You can kind of see that. I need a bigger though. Bolder. Looks like steps. Why would we have a step function? So what if we went to the store and we bought a sandwich? Or sometimes you go places and you want to buy, I don't know, sometimes you want to buy a sandwich and you say, but I only need like 4 bites of it. Do you think they just sell you 4 bites? So they tell you a whole sandwich, right? And so that's what it represents, is we can't buy like a part of it. Whereas a linear function, if we were to graph a linear line through this, let's do something like that. This would represent that I could buy a sandwich 0.3, a sandwich 0.2, a sandwich 0.1, whereas no, we have to buy sandwiches in wholes. We can do halves as well, and if we did that, then we'd actually create even smaller steps. But that's kind of what a step function is. A floor function is if I took, let's do floor. If my number was 1.7, the floor would be 1 because it's the bottom integer. If it was negative 2.3, the integer that's just below it would be negative 3. So it goes down. Whatever that number is, down. So that one's a little weird. If I had 0.5, okay, 6, it'd still be 0. Okay, so that's your floor function. Your ceiling function means that we're going to take the whole thing and delete all. Ceiling means we're going to take a number and we're going to bump it up. So if I had 0.5 or even 2, 0.2 would bump up to 1, to the next integer above it. And if we did negative 2.3, the next integer above that is negative 2. If we did 5.9, that would be 6. And if we did 1.3, that would be 2. We're just going to bump everything, shift everything up to the next. If on a number line, we're going to shift it to the number on the right of it, the integer on the right of where it is. If I had the integer, say 4, it still would just be 4. And so those ones just stay there. Okay, and so the greatest integer function, that's kind of was my point, was talking about this. Greatest integer function is more like a floor one. Yeah, it's more like a floor one. So if I have, and we represent it like that, some of these other ones are represented like that. Oops, I screwed up. Back. Floor is represented like that. The ceiling's represented like that because it looks like the ceiling. And then the floor. So the floor function, so like if I were to talk for 2.3 minutes, and we wanted, they're going to charge us for 3 minutes, right? So if we talk. They don't ever do point something minutes. They just flat out round up. That's what they do. So if you talk for 2.3 minutes, they're going to charge you for 3. And the way that we do this is we take x and we're going to add 1. We're going to take the greatest integer of that and then we're going to add 1. Because what this would be is this would be 2 plus 1 and that will give us 3. Because this started out as 2.3, but it'll become a 2 when we do the greatest integer function. It's just kind of interesting. It creates a step function. First thing we're going to do is, let's look at this. So I'm going to let you read this. And Miriam, did you have any questions? Jeffrey's kind of looking at me weird. But it's just kind of a weird, I think it's a cool thing, but it's just kind of weird. And it's also like if you were to go buy a shirt and you just tore off the sleeve, they wouldn't just sell you the sleeve. So there's certain things that you have to, it's not really a linear function. It's, you got to buy the whole thing. It's all or nothing. And so that's why it like steps up in prices. So like if a shirt costs $15, you couldn't spend $20 and get a shirt plus a little bit, plus the arm or plus the neck or the collar or something like that. That's just weird. Okay, so a payphone at a baseball stadium charges 65 cents for the first 5 minutes or part of. Oh, I totally screwed this up. My graph that I have isn't even the right graph. Oh well, we'll have to do it on the fly, which I'm fine with. And 22 cents for each extra minute or part of. Express the cost C of M as of an M-minute phone call as a piecewise function using the greatest integer function. So this one will kind of work together. So I have C of M, and when we have piecewise functions, we have 2 parts, right? So what is the breakup? For M being less than or equal to 5 minutes. And then the other one will be M over 5 minutes. So let's focus on this first one. For M less than 5 minutes, what would we, so if we talked 5 minutes or less, how much are we going to pay? Yeah, and just flat out 65 cents. It's not 65 cents per minute, and that's where I screwed up in my graph because I did that. It's just flat out going to be 65 cents. Okay, and so that's it. So if I talk 4 minutes, 4.5 minutes, 2 minutes, 1 minute, barely talk a point second, it's still going to be 65 cents. So what would our equation-y thing look like for M is greater than 5? I'm going to wait for Miriam to finish typing. Okay. So you both used X and used it differently. Which one do you agree with? I'll put M minus 5. And in case you didn't hear what Jeffrey said, he said that he would put X there, but X meaning the additional minutes. So the way to capture what you just said is by saying what the minutes are, but we're going to take off 5. Because those first 5 are in the price of the 65 cents. Does that kind of make, yeah. Miriam, are you good? Because I like what you did, Miriam, and you used an X, which I would have done too, because I always type X's instead of M's. But M for minute. And then what I want to do is I want to, oh wait, hold on. What do I have to do? It told us to use a greatest integer function. So the way to convert this into the greatest integer function, because remember that was just, it's a really weird, it's a weird step. So we're going to do 0.65 plus 0.22, and then we're going to do big parentheses. I'm going to use that bracket m minus 5. Remember, that's going to take you to your lower integer, so we got to add 1. We got to add that 1 minute because they're going to charge us for it. So that would be using the greatest integer function. That weirdness there. Do you see that weirdness there? Okay, but we had to do it like the greatest integer. That bracket there tells us we're going to take whatever we got. So for 6.5, then we're just going to take 6. Minus 5, we're going to get 1, but we wanted to charge for 2 whole minutes because 6.5 you got to round up because everybody's greedy. So you have to get for that extra little bit. So what I'm going to do is I'm going to show you how to graph this on Desmos. And I need a new share. Share my screen. I want to share my screen. And I want to share Firefox. Share. Gotta come back over here because this little guy goes super teeny tiny and you want to be able to see it. So I'm going to come all the way over here and go super big. Oops, that's not even decimals. Okay, so you guys can see it, right? I can't see what you can see, by the way. So what I'm going to do is I'm going to do y equals 0.65. And then I'm going to do the braces. Hopefully you can see those braces for x less than or equal to 5. Oh, and we better put above 0 too because you can't talk less than 0 minutes. 0 is like the lowest. Something went wrong. Oh, I didn't put an inequality there. Okay. And then we're going to do y equals 0.65 plus 0.22 parentheses floor parentheses x minus 5. And I use x, and you could have used m on both of them and it would have worked out. Then we want to add 1 minute. Okay, let's see what happens if we don't add 1 minute. See, can you see how the green line, the green, oh, I'm going to put my parameters in here. X is greater than 5. Oh, it didn't work out that way. Greater than 5. Can you see how the green and the red lines stick together? Can you see that? Okay, and that's what we don't want to have happen because after 5 minutes we actually get charged another 22 cents. That's why we have to come back here and put plus 1. And then that'll start to charge us an extra 22 cents. Because that floor greatest integer function is saying we're dropping down the number. So if it's 6.5, it's saying we're charging for 6. If we're 5.5, we're charging for 5. And we want to actually charge for 6 because any portion of talking we do above that. And by the way, it used to be really annoying in my days of when cell phones came about, which was, you know, oh so long ago. We had to do those things. So remember that really cool graph because everything else I have here I screwed up. I did this right. I set that up right. But I don't think I did that. That's if you don't put the step function in. Okay, if you don't put the step function, then that's a linear line that you get. But if you put the step function in, then you get that. And remember, I screwed up somewhere. Yeah, I screwed up because I multiplied by 5, so don't even look at those ones. Erase that in your brain. So let's look at how we would graph this one. And for this one, what I did is I gave you whiteboards. Let me find my whiteboards, week 10 whiteboards. So, pause for a second. What I want you to do is I want you to try to take over a whiteboard and try to create a graph of what you think it would be. And that might be a little bit hard. And if you can remember what student you were, and all of these ones are going to be a I'm going to make my problems smaller and make my whiteboards bigger. That's what I'm going to do. Because we only have 2 students, so we can make bigger whiteboards. That looks better. Let's do student number 5. Okay, so student number 1, I'm going to have be Miriam if you'll take over that whiteboard, and then student number 5, I'll have be Jeffrey. And Jeffrey, if you want to, you can use this. Or you could try using it on the computer. Okay, so what you need to do is you need to go up on the whiteboard thing. Good job. And if you click on this rectangle, it's going to give you lines and stuff like that. And I'm okay if you just have a linear function because we're going to pretend you can text to 0.02. And so I just think that this is going to be a cool exercise of using an iPad with Adobe Connect. We're just going to get the gist of it. One of the biggest things I wanted to do was just flat out show you that Desmos website because it's a pretty cool graphing calculator. And then of course when you're doing stuff, you can totally change the scale of what you're working with. So you can't really tell I did that. So like you can, you can make your scales however you want. I put it to where I can kind of see what's going on. 32, and then I put a 400 in there because I knew 400 was going to be important. And if I was to graph my very first where x is less than or equal to 400, it's just going to be a straight line to 400. Is it hard on the whiteboard? Yeah? And then also one thing you can do is you can put you can like get your arrow where you want it. Click on the thing and then move your finger and then it'll draw lines too. So it's just kind of weird stuff. And thank you for trying. And then you can send me a message and say, Miss, never do that again. That whiteboard was horrible. If you have an iPad, people like it. iPhones will do it too. If you have an iPhone, there's a Adobe Connect app to where you can do the stuff on there too. Good job. And I like how you're doing that step function. And if we weren't doing it, then we'd have a oh so slight gradual incline after that. And I think I've got it here. And then we'll go and, so that's if you don't do the step function, you think, right? It'll just be a gradual incline as we go up. And my niece once took my mom's phone, and my mom didn't tell me about it. And so she had a $300 bill my mom had to take care of because her grandchild did something that she didn't know she was going to do, but that's my mom's fault. So anyway, it's usually not so bad. We've figured ways to mitigate that. And Miriam's doing a step function, so I wanted to real quick just kind of go into Desmos again and show that step function there. So I'm going to share my screen, share Firefox, okay. And I can't remember what it was, 32 for x is less than or equal to 400. And then we're going to do 32 plus, was it 11? I think 11. Minus 400 plus 1 for x greater than 400. And this one we're going to have to go find it because it's gone. It's totally gone. All right, it was doing better. We're going to have to zoom out. And the problem with that is my picture is so far zoomed out that it's showing that it still is a straight line. So we're going to have to zoom in. And then you could start to see the graininess come in. If you zoom in a lot, you could start to see it. There it is, but it went away. So anyway, so you can still see that little stepper because you can't do a 0.5 of a text. A text is text. And so that's why it's not a straight linear. And I'm okay if on the assignments, if you're just doing linear, if you do that floor function, you're obviously going to impress me. But you'll still get full credit if you're just doing the, what am I doing? Cool. Anybody have any questions? So good job. Thanks for trying that whiteboard thing. That meant a lot to me. All right, guys, I'm done. I have nothing.